All right. Just for the start of the recording here, I'll stand where the camera can see me. Hi. My name's Christiaan Adams. I'm on the Earth Outreach team. I work with Google Earth a lot these days, as well as with Earth Engine, and a bit with our APIs. And this class is about the Google Maps API, which is a great tool for putting a map on your website and maybe publishing some of your Earth Engine results through said map. So that's what we're going to do today. This class is for folks who want to learn the basics of the Google Maps API and get your hands dirty with a little code. Even if you're not a coder, it's we're going to do the copy paste method. Anybody is welcome, and yeah, let's get started. All right. So what do you need to get started? You'll need a text editor, and we'll help you get one of those if you don't have it. On PC, I recommend Notepad++. It has a lot of great programming features. On Mac, TextMate is another good one. Or if you want to, you can just use the basic Notepad app or the basic text app on your Mac as well. They should work fine. You're going to need a browser, since what we're building today is a web page. So you'll need a browser to view it. And if you use Chrome or Firefox, they both have some great developer tools, debugging tools built right into the browser, which are very helpful. But as you learn how to do any programming, you will need some time. Takes practice and patience. I'm not a software engineer. My background is not computer science or computer engineering. I'm an environmental engineer and a GIS guy, a mapping guy. And I've taught myself a handful of languages, just enough to be dangerous, but get some things done. And it's all about spending some time with it, digging through the documentation and digging through sample code, finding other people's work that you can copy paste from and put the bits and pieces together. So that's what we're going to do today. And if you have friends who know how to program, bake them lots of cookies, because it's worth it. All right, so let's get started. First, let me go here. If you go to the conference website and to the breakout sessions page, and you find the My First Google Maps API section, which is this class, I've added a link to the slides here. I recommend you open those. And a Start Here link to the documentation. That's also in the slides. So it's both places right here. So this is the place to start. Come on, internet. There we go. So Google Maps actually now has several APIs. There's the original JavaScript API for putting maps on web pages. There's now an iOS API and an Android API for putting maps into native apps on those platforms. There are a bunch of other APIs like the geocoding API for turning addresses into latitudes and longitudes, and there's a whole bunch of associated APIs that work with the Maps API. But today we're going to focus on the basic Google Maps JavaScript API for the web. And if you go to the page for that, there's an overview here. When you have some time, feel free to read through this. It gives you some good background. But we're going to go to the guides page. And the first example here is in programming, every programming language you learn, there's always a hello world program, which is the first thing you do when you learn a new programming language. It sort of shows you the basics and print something out somewhere. And so we're going to sort of follow along with the hello world of the Maps API, and then add some interesting bits and pieces to it throughout the class. So let me get a few more steps in here, and then we'll pause and make sure everybody's set up with the text editor and ready to follow along. So on that guide page, if you go to at the bottom of the code there, view example, brings you to the simple map. And that's the basis for what we're going to use. You scroll down, it's got the sample code here. And we're going to copy paste that into our text editor. So Control-C to copy. I have a new document in my text editor. And there it is. So let's get everybody started. Make sure everybody's got a good text editor set up, ready to go, and that you get that code in there. I see people going like this. You've probably done the next step, right?
No, I can't get Notepad open. There it is.
Oh, okay.
So this is the hello world code?
This is that simple map code from this page.
Yeah, trust me, I'm not jumping ahead.
Yeah, okay. No worries.
You use Google Docs. Google Docs.
No, because that's a sort of formatting that'll stick all sorts of formatting in it that you don't want, and you can't. You're going to want to save this locally on the machine. Or is this a Chromebook?
No, it's not Chromebook.
Okay.
What do you recommend?
You can just use Notepad if is it Windows?
Yeah.
Notepad, or if you want to install Notepad++ real quick, I can recommend that strongly. You're all set? Yep. Excellent.
So just, this is. Yes.
You guys all set back here? You can do this on a tablet.
No,
Exciting.
no.
No? I want to see somebody try.
No.
Let's see if we can make that work. Good.
Yes.
Just choose one.
So I'll show you the first reason why I really like Notepad++, because if I go up to the language here and I select HTML, it colors everything so I can see really easily what's what in my file.
Not a requirement for the class.
Yep, not required, but it makes things a little easier. All right, most people, does it look like most folks are ready?
Yes.
Okay.
So we need a little more time here.
One here.
Okay.
Everyone else.
Give you guys another 30 seconds or so.
Where'd it go?
TextPad, that's a Mac application. Or no, I use Notepad++ and JEdit. For KML editing, JEdit has a bunch of tools for automatic schema checking as you're writing.
I think we're all set across the board.
Okay, good to go.
We haven't saved it though.
Right. Neither have I. In Notepad++, there's this little square symbol up there. Remember what a floppy disk is? It's red, and that means it's not saved. So I'm going to hit Control-S to save and put it on my desktop and do Apps API 2.html. So I'm going to save this as a .html file, all right, to my desktop. And if I go to my desktop, and I find that file, move these guys out of the way. It's this one here. I got this new laptop, and I still haven't figured out the resolution. Everything is way too tiny on here. So I open that HTML file up. It opens up in my browser, and uh-oh, what happened? Well, something's not working. Anybody else see that?
Yeah.
Okay. So I'm going to open up my developer tools and see if I can debug this. All right. There are a couple different ways to do this. You can right-click and select Inspect. You can go up to the menu and do More Tools, Developer Tools. You can click Control-Shift-I, or you can hit F12, and you get your developer console comes up. And it might come up over here, or it might come up down at the bottom. It doesn't matter. You can move it back and forth. But this gives you a bunch of tools. Let me actually drag it down and move it down to the bottom. There's a whole bunch of tabs down here. You can look at all the elements that make up your page. This is the console that gives you sort of your code output. We'll come back to that in a sec. You can see your network if you're like loading images or other files. It'll show you all the network traffic on this page. Performance, memory, application. You can dig into all sorts of things about a web page here. But in my console here, I'm getting an error. Interesting. This red line says Maps API error, invalid key. Well, if you noticed back here on the Maps API documentation, there's this get a key button. This is an API key. If you end up using Maps API on your website, you're going to want to get a key that's dedicated to your site, and that helps sort of track your usage of the Maps API, both for your own analytics and for Google. We track the free limits on API usage, things like that. And so once you go into production with this, you'll need an API key. If I go and look at my code down at the bottom here, I see in this line, we'll get into what all of this code does in a minute, but just to get something working, right here it says key equals your API key. Well, that's not a valid API key. So I'm just going to delete that for now, and delete key equals your API key, and delete that ampersand so that it just says JS question mark callback, etc. Right? Now if I save that, Control S, and I go back to my browser, and I click F5 to refresh, hey, I have a map. Woohoo! All right. So again, for those following along, delete the key equals my API key and the ampersand so that you're left with this. Can you guys see that? Do I need to make it a little bigger?
Can you make it a little bigger?
Is that better?
Yeah. I know.
Thanks for the callback.
Yes.
Why does it not use keys?
If you're doing local developments just on your machine, it doesn't need it. And I think you can do like some very small limit on your server, but I forget what the current restrictions are. But yeah, if you go to production, you will need one. Yep.
Can anybody guess where our Maps API team works?
Yes. Where do you think our Maps API team is located?
Perhaps.
Any clues? Sydney, Australia.
My brother lives in Bangor.
Excellent. All right. So we talked about keys. We talked about going in and finding the sample codes, copying that. If you're interested, all the code is also in text form in the presentation here. So, whoops, you can go in and copy paste out of here as well if you need as we go along. All right. We put it into the text editor. We saved it. We got our key error. Opened up our developer tools. Corrected the error. Saved and refreshed, and we have a map. Woohoo! All right. Where is?
And then you have to jump.
Question.
So the API key, that must belong to service account.
Not necessarily. You sign up for a key. You can sign up for multiple keys on one account. I think it's per server or something like that. Jordan, you know how to describe that?
Yes. All you need is just sign up for like one project,
Right.
and
It's
then
per
you can
project.
create a number of keys with the project. And then if you want to create more than one, if you have a project already and it's something else, you can create a key just for that site per se, or you can have one key shared.
So if you click on that Get a Key button, it'll take you to the API console.
Yeah.
You can set up projects, and then for each project, you can say, I want to enable these APIs for this project, and it'll give you a key for that project. All right. So this is the code that is in with a few minor modifications since they updated the site with a few comments in there, but functionally it's the same. This is what we have. Up at the top there, first line, we declare that this is an HTML document. HTML, for those who are new to it, is a subset of what we call XML. XML is a way of laying out data in a text file where you have these little tags. Like here's the body tag, bracket, body, close bracket, and then down here at the bottom, there's a bracket / body. That's the body closing tag, so the open and close tag. Everything in here is wrapped in open and close tags, and it can be nested, but just about everything has open and close tags like that. And that's how we structure the data and tell, that way the browser knows what each piece of information in there is by looking at what tags it's wrapped in, right? So HTML, type of XML, doc type up there. That one doesn't have a closing tag, by the way. Next one, HTML, and we come down here, but there's a bunch of stuff there that we don't need to worry about. This is the style section. That you may have heard of CSS, cascading style sheets, as the way of styling stuff in HTML. We're just using it for a few basic things like the height of the page and the height of the map right now. It says 100%, take up the entire page height, right? And then we get to the body. The body is the actual content of the page. And the most important part of that for us is this div right here with an ID of map. And that is where our map is going to get injected into the page. And we'll see why in just a moment, because next is this script. And this is where our JavaScript is. And that's where we're going to be doing all of our editing, is inside that section in this class. So I'll come back to that in a second. There's another script tag down here. This script tag says source equals this URL, which goes to the Google APIs, Maps API, JavaScript, P, etc. That's going to Google Server. It's saying, hey, give me the bundle of JavaScript code that does all of the Google Maps magic. Grab that and pull it into this browser session. And so that's getting all of the stuff that makes the Google Map work as a blob of JavaScript. And then what we write up here sort of controls that and says, how do we want to use that, right? There's a little detail here about this asynchronous defer stuff. You don't need to worry about it, but basically it means start rendering the page while you're loading that JavaScript blob. Don't wait for it. And then once the blob finishes loading, then kick off the rest of the scripts. Just a performance thing, in case you're wondering. So I talked about the styles. So let's look at the JavaScript here a little bit. In here, we define a variable called map, and then we define a function called initMap, initiate map. And the first thing we do is we create a new, or we take that variable we declared, we create a new instance of a Google map. New google.maps.map. And the thing that it needs to know is where on the page is this map going to go. So we go documents, which is our whole document, get an element by ID, map. So it's going to go find the element on the page that has the ID of map. And that's this div here that I told you is where the map is going to go on the page. All right. And then we do a couple other things that need some parameters, like where do you want to start the map off? What's the center of the map for starting? And at what zoom level do you want to start? So that's center and zoom right there. So let's try making some changes to these things. First thing I'm going to do is get rid of these comments. They annoy me. First thing to do is make the map, instead of 100%, let's make it 600 px, pixels wide, and actually, yeah, and then width 800 px. And then down here, I'm going to change my latitude and longitude and my zoom level. I'm just going to grab those two out of my presentation and paste them in here. Oops, correct my indentation. Okay, so I've edited my center latitude and longitude. Previously, it was the latitude and longitude for Sydney, where the map started. All right, so I've made those edits. Anything else? Oh yeah, let's add one little HTML element up here. I'm going to add a title. In HTML, H1 is heading level 1. That's your title text. And call this my first Google map page. H1. You saw how I did the, what's that?
Google.
Google. There we go. Thank you. So opening tag, closing tag, my text in there. All right. So
That's H1, right?
H1. Sure. All right. Let's go and refresh that. See what I get. Hey, look at that location. So, let you guys do that. You're all looking at your computers.
Can you just go back to?
Go back to the code. Yes, of course. Sorry. In fact, what I should probably do is go back to this page, which gives you all of those details. Yep. You can copy paste these text blocks out of the slides if you want. Zero is zoom over, and we go into the high points now. I think you can technically force it higher, but we don't have to.
So if you change the last one.
All right.
It's up to like 27
The direct coordinates, so- Okay.
Yeah, you can zoom out and see where you are.
Oh, that's not between it has to be between 0 and 1. I don't think one. So that's why I was like, you might have put an extra.
Yeah, be careful with the center latitude and longitudes. The negative signs change because we're in a different hemisphere now.
I got my title, but I lost my name. So what did I do?
You don't have to do it that way.
Oh, so you edited in the HTML body stuff instead of
I lost my zoom here. I don't know. Is this zoom out?
Mouse wheel will do this. You go back to the slides.
Oh, there we go. Okay.
You resize the map.
Great. Okay. Somewhere random.
There, so you got the, probably this center lat. Yeah. Not that, just a center.
I did it.
Yeah, you play with it. I hate to play with scroll like that. So
Yeah, I probably got pasted a piece of.
So how do you do it? Oh, you're missing a colon. Semicolon.
Also, you do
I'll let
Debugging.
somebody else help debug that. Everybody else? Good?
We're supposed to get
Almost. Where's your code? Did you edit the zoom level?
In my head.
Yeah.
And this is what it says.
Oh, you have parentheses there too. Instead of a Carrot.
Good job. Very good. All right.
Okay, try that again.
You may want to pick that one out, but it would be a very boring session.
That's right, and I will name it. Thank you.
Thank you very much.
Jordan, or Joel,
Yes.
this one was having trouble.
Okay.
Higher level the zoom, the more you're zooming. So.
Yeah, so zoom level 0 is zoomed all the way out. And I think we go up to 27 or 28, at which point you're seeing just like a couple feet on the ground, right?
Okay.
All right, I think we have one person still debugging, but I'm gonna keep going with the rest of you. So, well, this is pretty cool. Oops, where are we? We've created a web page and we've added a map to it. Fun, but not very useful yet, right? So let's see. What can we do to start customizing this map to make it the way we want? First, let's, you know how we have these controls up here for satellite, with or without labels, and we have the map and the terrain view, all the different map types. Well, we can control that with the API. So if I go back to our documentation and find the section on map types, go back to guides, map type, the page on map types. It talks about the 4 basic map types. We have a road map, which is the basic Google Map view. We have satellite, which is the satellite imagery view. We have hybrid, which is the satellite imagery with the labels on it. And then we have terrain, which is the sort of road map view, but with contour lines and stuff like that. So in the API, we can tell it what map type we want to use. It defaults to the road map, but in the sample code here, I can see map type ID satellite. Hey, that's interesting. It's also in my presentation here on the next page. Oh, that talks about the 4 types, then map type ID satellite. All right, so I'm going to copy that. Why is that not working? Anyway, so in my code here,
Wait, where did you get that?
this one's simple enough, you can just type it in. So you can watch for a moment here, map type ID, and the capitalization is important. This is what we call camel case, where it's sort of all squished together, but the first letter of each word is capitalized, so you can still read it. Map type ID, quote, satellite. Now there's one little gotcha in here, which is that this is a JavaScript list. See this curly bracket here and here? This is a list of things, center, zoom, map type ID, And in a list, the items need to be separated by commas. Well, there wasn't a comma after zoom because it was the last item in the list, but it's not the last item anymore. So I need to go up and put a comma after the zoom level there, right? It's a common gotcha that you miss a comma in a list like that. That'll bite you many times before you learn your lesson. It did for me at least. Okay, so I've added that. I can go and refresh my map. And now by default, it comes up with a satellite view. So you've customized your map a little bit. Got it? Good. Everybody got that? Map type ID, satellite? All right. Let's talk about map controls. there are a bunch of controls on the map. Basic things like your zoom control, plus and minus buttons there. Your map type control, where we can choose satellite or hybrid or all those things. You have things like the street view control, little peg man there, you can drag them out and you can see street view. That might not show up on your map right now because by default it's probably not on. But you could turn it on if you wanted to. On some maps you get the rotate controls or the scale control down here if you want to turn on a basic distance scale. You can turn on a full screen control, so you can add a full screen button that lets the user expand the map. Those are all controls that are available to you. Some of them, as you can see, appear by default on your map. Some of them do not, so there are options. And some of them have various options, like we can choose what type of map type control we want and what position on the map we want it to be in. So let's, yeah, there's a default control set that automatically adds some of the controls to the map, and it actually sizes them based on the map size. So if I shrink, if I've left my map to be, say, 100% of the page, and I shrink it down, at a certain point, the controls are going to change to a more compact version of themselves, and then at a certain size, they might actually, most of them might disappear. Say, if somebody opens up your map on a mobile screen, on a small phone screen, you don't want the controls taking up half of the map. They get out of the way automatically. But you have control in the API over which ones, to say, no, I want this control to always stay visible, or things like that, right? So let's add some control. Oops. Let's add some controls here. I'm going to copy these guys out of the presentation and put them in my code here. And they go down below my map type ID. I have to put a comma in there again. Tap these guys in so they're nicely lined up. Okay. So what I've told it is I want my zoom control to always be there, no matter how small my map gets. Always leave the zoom control visible. My map type control, always leave that visible too. And my map type control options, I want to set it as a drop-down menu instead of the normal 2 buttons up at the top there. Makes it a little more compact, so I'm going to choose that option for the map type control. And then I want to show the scale bar at the bottom there that I showed you. So turn that one on too. All right. So let's save all those options. Go back to my map. All right. So not much has actually changed, except that this is now a drop down, and my scale bar shows up at the bottom here. All right.
Can you go back to the comment?
Yes.
Sorry.
Yep, that's a good reminder. This right here.
Did you?
Right,
Did you want to just copy it?
Oh,
It's
maybe
easier.
it's an image. It's going the other way.
You can't, it's an image.
No, it's not. It's text.
Oh, those text, yeah, go back to the slides.
That's how flexible I am.
Who's that?
Yeah, sorry. That's text. Yeah.
So it's this right here.
Yeah, don't bother with the pan control. I think that doesn't exist anymore. I should just delete it.
See a tab number.
Don't with the presentation and readability, so it will still work if you all really, but it just makes it harder to read it.
All right. Everybody get their controls up and working?
Yes.
Yes, good, good, good. All right. Let's go on to the next thing. So we've added a map to a web page. We made some customizations to the, the background of the map and the controls, things like that. But what we really want to do is start adding some data to the map. So we have a bunch of options here. We can use the API through JavaScript to add objects to the map. like markers or points, lines or polylines, polygons. In fact, there's some extra JavaScript libraries you can pull in that will let you easily define a rectangle or a square or a circle, things like that, if that's what you want to draw on the map. You also get control over the info windows. When you click on a marker or an object on the map, you can say whether or not an info window pops up, and if so, what content does that have? Does it have some basic text? Does it have fancy HTML layout inside that window? You can do all that kind of stuff. We can also do overlays. So these are all things that these first four are ones that I can do through the API and actually have those JavaScript commands to create each of those. Or I can pull in existing data sets, like say a KML file from Google Earth, or a tile set that I might have exported from Earth Engine. And we'll get into that a bit more in a few minutes. I can do overlays on the map of various sorts. So let's start with markers. Let's just add a marker to the map. Again, in the guides section of the documentation, find the page on markers, and there's lots of information there, all sorts of details about markers and how you can customize them and add them. But let's do something basic here. And on this page in the prezo, I'm just going to copy that text out. And I'm going to put it somewhere a little different in my code. So be careful here. We are no longer working in the map initialization. This is we're still in the map initialization function, but we're no longer initializing the map with this block right here, right? This is our map initialization with all of the options here. Now we want to add something on top of the map so it actually goes below this curly parentheses semicolon, right? Next section. So I'm going to paste it in here. Tab it over. All right, so what have I got here? I have one line that sets up a new variable called myLatLong, and it has a latitude and a longitude. Great. Start another variable called marker, and we initiate a new Google Maps marker. And a Google Maps marker needs to know a bunch of things. It needs to know what is its location. Well, we give it position, myLatLong, which is this latitude longitude variable we just defined. And we need to know what to do with this marker. What map do you want to add it to? Well, I want to add it to the map that we called map up there, right? That's the variable for our map. It's sort of redundant. It needs to know that. And then there are a bunch of other options, like you can give it a title. So give it a title. I'm going to say hello world. All right. So I'm going to save that. Go back here and refresh. And you should get a point on your map. And if you hover over that point, you get your handy little tooltip with the title on there.
Oh,
Gee whiz. So now, sorry?
It's Purdy.
Purdy, yes, it is Purdy. And you now have the building blocks to do all sorts of fun stuff. You could, use your JavaScript to query your database for your point locations of certain things, and then render them on the map. All, using JavaScript on your page here, right? It gets into some fancy stuff, but you can do all sorts of things with this code now. If you can, hook it up to other stuff on your server or things like that, right? We're not going to get into all that fancy stuff, but yeah, it's all documentation. And you can copy paste the documentation, get it to do it. So let's customize our marker a little bit. Shoot. Sorry. The next page in the prezo has this, adding a different icon. And the important parts of this code are what are highlighted here. We set up a variable called image that points at an image file, in this case a PNG file. And then we add something into our marker definition that says icon : image. Use that image for my icon.
Don't copy and paste the whole block, just the kind of bold stuff. You already have most.
You can either just copy paste the bold stuff, or if you copy the whole block, then you can blow away the existing block and paste in the new block.
Oh, you still need the lat long.
Oh yeah, I lost the lat long, didn't I?
Be careful.
Oh.
Just that, the first line.
Well, I thought it was pretty before.
Exciting stuff. Punctuation error. Yeah, if you get weird errors, check your punctuation. Check that you haven't put things behind the wrong parentheses or the wrong brackets, so that you haven't left out a comma somewhere. JavaScript is not very forgiving of what we call syntax errors.
Where we created a variable for my lat long, could we have just put the position in with a
You could,
list? Is it whatever?
you could have put this in here.
Right there, okay.
Yes. All right.
And I can understand reasons why creating a variable makes a lot of sense, but I just want to make sure I understood.
Yep. Yeah, in this case, it doesn't, for a very simple example like this, it doesn't really matter which way you do. But as you start developing much more complex code, it's good practice to break certain things out for clarity, either clarity of reading or just,
And you're gonna,
yeah,
and you're gonna keep pointing to the same thing.
exactly.
You're gonna make a mistake in different places if you keep on. Inadvertently, yeah.
That's a big part of the skill behind a good software engineer, is knowing when to put things in line or when to break things out into separate, not just separate variables, but entire separate functions or entire separate code blocks. How to structure complex code that has lots of interconnections between thousands of lines. Then you need to really think about that stuff carefully. For this example, not so much. All right. Looks like most of you are ready. So we added a single point to our map. We changed the icon to a bright sun, exciting. But what if we want to add some bigger data sets? So we're going to add some layers.
Question.
Yes.
Where is the image for that icon stored? If you just
That-
your computer.
That particular image, you can see it's a URL here. I chose one of the icon files hosted by Google Maps, but it can be any image that is publicly accessible on the web. It can be on any server, anywhere. It can't be on your local computer. That won't work, right? It has to be accessible on the web.
Well, running it from your laptop, it would work, but it would only work for you. The browser
Would
fetches it? Yeah, the browser fetches it. Yeah.
The browser would fetch it locally.
Yeah.
Okay. Yeah, might work.
It's not like a KML overlay. Yeah.
Right. Okay.
This already should be a PNG format.
Yes. Yeah.
I think PNG,
Or
GIF, or JPEG should all work.
yeah, any kind of major graphic that's supported by your browser will work, I think, including SVGs.
Yeah, SVG will probably work. WebP will probably work. I don't know about TIFF.
I doubt TIFF. That's not a very common internet. I get a get bigger PNG if we say or GIF.
All right.
Wait, if it was this, if you have a symbol that literally.
I don't know if it would animate or not, to be honest. You have to try it. It might.
I was wondering that too.
You got an animated GIF? I don't know. Theoretically, it might. I don't know. I've never tried that.
Okay.
Yes, keep trying.
Oh, you just do it?
Stack Overflow says so.
Oh, okay.
Stack Overflow is your next great resource after after the documentation. All right, so let's add some layers to our map. There's a whole bunch of options here. First, we're talking about these three, which are sort of the Google Maps provided layers. If you've ever turned on the traffic layer in your Google Maps, or the transit layer, or the bicycling layer, you know what those are. Those are sort of built into Google Maps, and you can toggle those on or off as desired. But up here are more interesting ones. So you can add a KML file. KML, for those who don't know, is the also XML-based language for creating content for Google Earth. Lets you, create points and lines and polygons and overlays and all sorts of things, and the info balloons, all that stuff. But you've probably, at some point in your life, downloaded a KML file and opened it up in Google Earth, right? You can do the same thing in Google Maps. It supports most of KML. There's a bunch of documentation on the limits in Google Maps. There's some size limits and things like that. But great way to get, especially vector data, points, lines, and polygons in, and some limited raster overlays. Another interesting layer type is fusion tables. Fusion tables is sort of Google's online database in Google Docs, in Google Drive. Lets you upload tabular content, including KML files or a CSV file that has latitudes and longitudes or addresses, so you can get some geographic data in there. And it'll create maps itself, or you can serve a Fusion Tables layer directly to the Maps API. In fact, that gives you some really powerful options, because Fusion Tables has its own API that lets you query the table as if it were a database with essentially a SQL-like database querying language. And it'll let you, filter that table by date or by, whatever data you have in your table. You can filter and sort it. You can also do some basic geographic queries. I believe it supports point and polygon. Like, say you have polygon, a rectangle defined by some coordinates. You can say, give me all the points out of my Fusion table that are within that polygon. Or I think it's like a circle query. You can say, give me all the points that are within X distance of this latitude and longitude. So some basic geographic queries. Anyway, working between the Fusion Tables API and the Google Maps API, you can do some cool stuff. And then the Google Maps data layer, JSON and some other options there. There's another one here, which we'll get to, which is adding a set of tiles, so raster data to your map. But first, let's look at KML layers. Presentation, there we go. So we'll go to the KML and GeoRSS page here. And it talks all about KML and the various options. And there's some links over here on the right to which KML features are supported in maps, stuff like that, size restrictions, all those kinds of things. Lots of stuff. But we will, some of the restrictions to be aware of. You have a KML or a KMZ file. The size limit on the file is 3 megs. If a KMZ file is a zipped, compressed KML file. And so if it's a KMZ, it can't be, the KML file inside can't be any bigger than 10 megs. And maximum of 1,000 features. use network links in your KML, it'll only follow 10 of them. It's advanced stuff.
What's the network link again?
Network link is a type of KML file that points at another KML file somewhere else. So it'll follow those network links, but it'll only go 10 dB.
So if you've got a Google Earth tour and you pull it out as a KMZ, you could pull it in this way.
Into maps.
Yeah.
So if you look at the page of supported KML elements, you will see that most of the touring elements are not supported in maps. They will only work in Earth because there's no like timeline user interface in maps and all those. There's a touring is one of those sort of advanced things. Like also the time elements in KML won't do anything in maps. So there's a bunch of stuff like that. But the basic, point line polygon, styling, that kind of stuff mostly works. Okay. So what I have done is in Earth Engine, I wrote a little script that created a feature collection with 5 points in it. I picked 5 semi-random points in the Bay Area here that represented various land uses from commercial, residential, forests, wetlands, etc. Just as some sample data to play with, and I used the export table function in Earth Engine to export it to a KML file. So if you have vector data in Earth Engine from whatever source, you can export it as KML. And I happen to put it in a Google Cloud Storage bucket. So it's just a handy place to put a file and quickly get it up on the web in a public spot. So I've gone ahead and done that for you. We can see here where that KML file is hosted. It's in my EE demos bucket in the EEUS folder. And if I copy this code and put it into my website code, there we go. So we create a new variable called land use samples, instantiate it as a Google Maps KML layer. And Google Maps KML layer needs to know where it's getting its KML. So we give it the URL. And then it needs to know what to do with that. We want to put it on the map called map. So if I save that, go back to my map, voila. I have my 5 points from my KML file on my map.
We did also change the zoom.
Yeah, I was gonna say, is that
Yes.
because of the,
So by default, when you load a KML file, it will automatically zoom to show the entire contents of the file. There's another API command you can put in there to override that and say, don't do that. But by default, that's what it is.
So that will always override the maps zoom.
Yes, if you set a zoom level or a view window and then you load a KML file, it will always by default go to that. But it's just a one-line addition. If you don't want it to do that, you put in one little extra option in that KML thing, and it will not do that for you.
Oh, how can we change the order of the submarker and the others?
Of those two icons?
Yeah.
That is a good question. I think there's some Z ordering control.
There is, yeah, there is a layering ordering where you can say that like this layer should be on top of this.
Yeah.
I forget what it looks.
It's in the documentation.
Yeah, it's in the documentation, but yeah, you should be able to specify, which data.
You can, look up layer order or Z index or some of the common terminology for that kind of thing. If I click on these, you see it gets a little default balloon that has, the data that I associated with that marker in the KML. If Everybody got a KML up?
Render it,
Good, good, good.
API,
Okay.
reach out that KML, take a picture of it, and then send that to them. But it
What
has to be-
time are we going till?
2:30.
2:30. Okay, so you still got 30 minutes. Oh, cool. Yeah, I think I'm doing all right.
Drive with
We're almost ready here.
Google Cloud Storage will work.
You guys are rocking.
Yeah, all of them are very level with, you know,
All right. So we added a vector data set to our map. How about raster? So much Earth Engine stuff is raster. We should talk about that. So I have this basic Earth Engine code where I actually grabbed the example code for our NDVI that pulls in the modus-based NDVI data. I think it defaulted to 2012, which is fine. It applies some palette to it to get its coloring. And then I added this export.map to cloud storage function. It says take my image, my NDVI, and render it, because NDVI natively, based on Modus, has Modus has all these bands that represent infrared and ultraviolet and blah blah blah, and that's not going to show up well if you try to view it in a normal world. You want red, green, blue image, right? RGB for basic visualization. So we need to tell it how to visualize it, turn it into a regular RGB image for normal visualization. And there are a bunch of options here. I can give it a name, I can tell it what GCS bucket I want it to go into, what folder, file formats. What we're doing here is we're going to export map tiles. And the file formats, it can be JPEG, PNG, or auto. JPEG is much more efficient for most raster data. It compresses and makes a much smaller file size, but it doesn't support transparency. PNG makes bigger files, but it supports transparency. Auto will automatically detect if that tile has transparency. If so, it'll write a PNG. If it doesn't, it'll write a JPEG. So that's a handy little advanced trick. And I want these tiles to be public, yes. And I want it to go from zoom level 0, which is zoomed all the way out, to zoom level 14. Since that's actually pretty far past the maximum zoom level of the modus-based NDVI data, which is pretty coarse, but I want the tiles to go down to a certain level, but not all the way down, because that would just be a lot of extra data that I don't need. Oh, and I don't want the entire world, because that Modus NDVI layer is global. I just want a bounding polygon. I drew a box around the Bay Area and just explained that. You'll see it.
Can you say again, so the file format order means what?
That it automatically chooses JPEG or PNG
Depending on
based on
whether it
whether it
says-
needs transparency or not. Not something you need to worry about in this case. So again, I did this for you, and the tiles are up in my Google Cloud Storage bucket here. And you can see that when it creates a tile set like this, it creates a folder structure that Google Maps knows how to read. The first level of folders are the zoom levels, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And if you dig into one of those folders, you'll see, again, a set of numbered folders for the X coordinate. And then dig into those, and you see another set of folders for the Y coordinate. And then inside there will be the actual image files, right? And so Google Maps knows how to traverse this folder structure to find just the tiles it needs for the current zoom level and view window of your map, right? And Earth Engine will automatically create that correct structure for you. So there's a little bit of fancy code needed to actually render this. You could do it much more simply by just pointing at the tile set and say, load these tiles. But the issue you run into is that unless you have a global tile set that covers the entire globe, your user is going to go to areas where your tiles don't cover, and it's going to be requesting all these tiles, and you're going to be sending all these bad requests to your tile server, and have a lot of network traffic that's unnecessary because there just aren't any tiles there, right, in your data set. So what most of this code does is it looks at the zoom levels, it looks at the bounding box of the data set, and it tells the API when to request tiles and when not to request tiles based on what your min-max zoom levels are and what your data area is, right? So lots of fancy stuff going on in there, lots of weird slashes to escape the URL. But basically what this does is it points the Google Maps API at that tile set and says, load these tiles onto the map. There's probably a simpler way to do this, but I did not have time to figure that out. I was putting this together the other day, so we're going to stick with this because it works. So I'm going to copy that, put it down here. Indent. And again, what we're doing is we're setting minimum zoom, a maximum zoom on my data set. This is my tile prefix, so this is the name of the path where the tiles are. I'm defining my overlay map type as a new image map. And then I have this get tile URL function that goes and sees if I'm within my zoom limits. If I'm not, return null. If I am, then construct the right request for the right tile based on all these, my current zoom level in X and Y, right? And it puts together that tile request and then it sends the request. Oh, and it has to know what size the tiles are. The standard tile size is 256 by 256. And then it pushes that to the map. All right, so if I hit refresh, voila.
So G should be get.
In GCS, are the tiles, are the files tiled already, or is it tiled based on the size you tell it you're going to code there?
No, it exports the entire tile structure to.
Oh, okay.
So in that folder structure,
The
you go to
GCS
zoom
folder.
level, if you go to the first 0,
Yeah.
one time. Go to zoom level 1, there are 4 tiles.
Mhm.
Go to zoom level 2, there are 16, right?
The tile size that you put in the HTML code have to match what's in the GCS folder.
If you zoom out,
The standard is 256 by 256. That's the standard that Maps expects.
Sure.
And therefore, that's the standard Earth Engine exports.
Mhm.
You could probably override that.
So why would you ever do
That's,
that?
no reason to. That's what works most efficiently in Maps. I believe that's what our native tiles are as well.
What's that? That's the
Tile size.
Yeah, 256 is like the universal. Well,
Cool.
basically everything.
But it got a raster layer on the map. So you can see how if you have your own Earth Engine data, you could export that to a tile set right now and throw it up on a map. Take you about 5 minutes, right? Sweet. Yeah, I think that's it. We're a little early, so
to draw
questions?
this, if you want to draw the polygon, in this case, you would want to, right, to bound it. Are there any tools to draw the polygon to get the coordinates?
So in Earth Engine, I drew the polygon to limit my tile school. But you're talking about drawing polygons in.
Well, even in
Maps
Earth
data.
Engine, you probably have to know so in your code, I think you have listed all the coordinates. How do you get those coordinates?
Earth Engine has.
In the Earth Engine code, you mean?
Earth Engine has a drawing tool. You can also define it by coordinates. Also, the Maps API will let you turn on a drawing tool for polygons, and you can let the user draw polygons and then give you the coordinates of it as well.
So yeah, what I actually did in Earth Engine, I set my bounding polygon there.
Right.
The way I got that is I used the drawing tools down here. I drew a shape and it comes up at the top of my code as an asset. And in that code, there's a little option like show me the code behind this. And I actually copy pasted that into the code here so it was all in one place for you to make it simpler. But yeah, if you use the drawing tools in Earth Engine, it'll show you the actual coordinate code behind that, what you just drew. Good question.
Yeah, I was wondering, is there, I'm thinking I'd like to share some Google Earth Engine data with colleagues. They're gonna wanna know what the values represent,
Sure.
right? So like, having
You want a legend?
both, well, I want a legend and a query,
Ah,
or a query.
You want like a point inspector?
Yeah.
Okay.
All right, so there are a bunch of options here, and this starts to get into the other class I'm teaching today, which is the analysis impact, which shows an overview of a range of tools for doing, publishing new data. This is a deep dive, or well, a shallow dive at least into one of those tools, and that's API. That said, what you want to do, you can do it in a variety of ways. If they are an Earth Engine user, then probably the easiest thing to do is just share a link to the code and or use the UI elements to make a maps with knobs type thing that they can easily do in Earth Engine. If they're not an Earth Engine user, then you have a few options still. One of them is to use Maps API, get it up on a map, and you could get fancy and use the Earth Engine Python API, have your server talk to that, and actually set it up so that when the user clicks on the map, it goes to your server and triggers a Earth Engine request to go to that data set, get the values, send them back, and render them either in a balloon or somewhere else on the page, however you want to do that. That's, the most sort of interactive live way to do it. You might have sort of a pre-rendered version of all the values on your server somewhere if you want to query Earth Engine directly and query that instead. But
In Tyler's class on the Python API, the web apps app class, will show you that kind of dynamic example.
Yeah, I did that yesterday. Yeah.
Oh, you did? Okay, yeah, that's.
yeah, so we know how that works better than I do.
Very competitive. But you also use that to follow the image.
From the Earth Engine API? Yes, absolutely.
It might not be the best way, it might be better to use.
Right, but so you can absolutely do that. Like, you can write your website to have some controls on there and say, have a year picker for NDVI and say I want 2012 June to August and dynamically create the Earth Engine requests to go to the Modus data, get me these dates, do the NDVI calculation, and return an image. And Earth Engine will do that for you. And in that case, what it's doing is it's actually, as part of that request, you will send it the zoom level and the bounding box, and it will only render the tiles live, on the fly for that current request. It's not going to render that entire, resolution tree of tiles. So that's totally good.
Can you set the map to update itself? So if you wanted to update NDVI every week, can you set it to do that?
Sure. Depends how your data is changing, what the best way to do that is. But one way is every week you could have some job on your server that generates the new tile set and just replaces the old one. So that, when you don't have to change your Maps API code at all, it's just pointing at the same location, but the data at that location changes. That's one way to do it. Or you could have something in your JavaScript that, if the new data is in the new location according to that date, you could have something in JavaScript that changes the URL it requests for the tiles based on the current date and go get that data from the location. Or you could use the Earth Engine API to make the query with the current date as part of that query. Like maybe NDVI generated on the fly from Earth Engine. Right? So there are a bunch of ways you could do that.
I may have missed this, but now that we've created this map, how do we share it? Or how do we make
So,
it live?
This is an HTML file. You put it on, as a page on your website, or you could host it as part of, a site you build on App Engine or on, I could take that HTML file and put it up on Google Cloud Storage and, I'd have a public URL for that HTML
So you
page.
basically just copy and paste the code that we developed.
Yeah, and again, that's a super bare bones web page, right? There's nothing but a title and tab on it. But, if you have a web developer, you have a fancy website for your organization, maybe you want to put a map with that kind of stuff on it. You could give that code to your web guy and say, take the map bit of this and put it into a page with all our normal stuff around it, right?
Tyler also teaches a class during this summit, which goes through like setting up an app engine site.
Yeah, App Engine's a great option for hosting.
Go to that
sites.
class and see like the steps that are required to do.
Yeah. Great.
What will happen if we, the raster layer, we will add a different projection? And will it be automatically converted to the one by default in API, or do we need to reproject the map before?
Yeah, so in order to show it in Google Maps, the tiles have to be in the right projection for Google Maps. Yeah, so when you create the tiles, you have to create them in the right.
Yeah, because it might happen when we use when we create the raster data using like other QGIS or
Yes.
stuff.
Yeah. If you're doing it in Earth Engine and you do export tiles, it'll automatically put it in the right projection. Earth Engine does all the projection conversions on the fly. But if you're doing it in some other software, then you have to be careful that you have the right output projection.
I see. Okay.
If you were just using the Google site, you could just embed a HTML box in the Google site and put the code in there, right?
You mean Google Sites?
Sites.
The Sites product?
Yes.
Sites has limits on what you can put in as sort of raw HTML and JavaScript for security reasons, so that people can't like put in malware code into the Google Sites page and then have that malware hosted by Google because it's on the Google domain. So for security reasons, there are pretty strict limits on what you can put into the Google Sites page. I think you would not be able to put this level of custom JavaScript in there, but I'm not sure.
Settle for the import a map.
Yeah, so
All the maps.
I forget if you can do random iframes.
You know, the classic sites you could.
Yeah, if you can put in any iframe, then put in an iframe object into your sites and just point it at this HTML page wherever it's hosted on cloud storage or whatever, right?
Yeah.
And that way you would want to make the map just take up 100% of the page. Whatever the size of the iframe is, it'll adapt. Right? That's another way to do it. Of course, if you want extra controls on the page that interact with the map controls, then you have to adjust your HTML.
Can you do a sample?
Sure. You're gonna ping it to me?
Yeah.
Hold on, I gotta get in my email.
Or an email. This is from last year's summit and class that I thought actually was.
Let me actually pull it up.
Maybe it's EE-summit-2016.appspot. So this is a bit of an advanced apps API example, talking to Earth Engine through the Python API, and it shows you kind of the concept of letting an anonymous user define some parameters. So let me, it might be easier if I just do it. So if you click this is a sample of the Landsat and Modus a land cover type upscaling. So basically what I allow the user to do is to draw a square using the drawing tools in Maps API. And then I also provide a little form slider that lets them decide how many training points to put in this. And basically what it is it's going to plot, 9,365 training points inside that square that I defined. And then it's going to cross compare the Modus data set with land cover and the higher resolution Landsat data with its RGB color and provide me an upscaled result of what that land cover actually is. So if I run the get results, you'll see that it produces 3 different layers. Takes a second to run sometimes. Yeah. So for example, you can see that this is the upscaled. So this is the original Modus data set, which is very coarse. You can see the Landsat I compared it with, and then the upscaling result where you see which is a little bit finer and more detailed than the original Modus data set. So, and then if I wanted to rerun this analysis, I just draw a new rectangle on a different area, that maybe one that actually crosses the Nile, and then maybe run just a few more training points, and then go ahead and rerun the analysis, give it a chance to load.
So this is dynamically.
Yeah, this is dynamically hitting Earth Engine directly to do the result, which is why it takes a couple seconds to actually run.
This is behind what you're actually seeing on in the browser here is the Google Maps API instance, like what you just created, and then a bunch of HTML elements to add the text and the slider and the buttons and things like that.
This
And
thing's-
a bunch of JavaScript to wire it all up.
There we go. That's better. This thing gets finicky if you define too large of a polygon and ask for too many training points. You hit the deadline exceeds on Earth Engine pretty quickly. So you might have to have stronger constraints depending on what you do. But there you can see how, because my training area was over the river, you can now see the blue a bit more defined in the result. But that's
You are calling some JavaScript or some of the taking scripts from Maps API.
yes, yeah. So I'm doing Maps API and JavaScript here. I'm also doing a little HTML form stuff here. And then once the user hits go, I'm actually using the Python or thinking Python API to do that on the fly execution of that analysis. And you can learn more about this kind of integration at that Earth Engine Python API web app class that Tyler teaches.
So there's the HTML code that lays out the page. There's the JavaScript that brings in the map and constructs the JavaScript requests of all the settings there. That goes to his App Engine app, and there's some code in App Engine that then constructs the Earth Engine request, sends that out, gets it back, and pushes it to the map.
And all this shows are pretty highly familiar. So remember your div with the map in it, in the HTML, including JavaScript, and then the only thing that I did differently is the JavaScript for the actual Maps API stuff is here. Go ahead and move to here. If you look through, you'll see that now your basic map options, you're creating a new map. I'm setting up the drawing manager. That's how you can draw a polygon. And then a few event listeners to listen for when the user clicks on the buttons. And that's what sends off the request to the, it's a couple hundred lines of code in total. Do the whole thing.
Awesome. Yes.
Is there any way to, on a location aware device, like if I'm on my phone, if I pull up a map like this on my phone, can I see where I am on the map?
Yeah, there are things in Google Maps API that let you put that typical blue dot on the map or zoom to current location. I think it requires that the user get a allow this app to see my location approval first, but once they do that, it should work.
We should probably break.
Yeah, I think it's the geolocation section. Let you guys out a few minutes early. See, it's asking for.
It won't work unless you say yeah.
Yeah, I know.
Okay.
There. Navigator, get location, or get current position. That's what the code looks like for it.
And to be clear, that's not even actually a part of the Maps API. That's just one of the JavaScript.
Geolocation
natives.
API.
Yeah, geolocation is
Yeah,
just part of the browser's JavaScript native API. So like if you want to build a geolocated web app, you can use some of that, mix it in with the Maps API to show the user's location on the map, or what you want to do. So like, yeah, so that navigator.geolocation is not exclusive to the Maps API. It's just something that browsers can do.
Okay.
That's based on the user's IP address.
On a laptop, yeah. Whatever your device is able to provide as far as the location. So on a cell phone, it can be much more fine-grained. And you can even specify in the JavaScript code how good of a location you're looking for. So like, for example, if they are on a phone, but you just don't care that much, you can do like a quick coarse lookup, which would be like GeoIP based, or cell tower based. Or if you can ask for a fine location, where then when you ask for it, the user says, okay, it will actually turn their GPS device on, get a lock, and then give the result back to the browser.
Cool. So you guys are all programming experts now. You're gonna be whipping up mapping sites like nobody's business. Awesome.